Thermodynamics' first law stated that energy cannot be created nor destroyed but transformed. For this project, this submarine is powered by nuclear reactor. The boiler generates steam from the reactor, which then entered and powered the main turbine. The power generated from the turbine will be delivered to the propeller of the submarine to produce propulsion.
We perform energy balance equation to solve one of the given question where a field assumption is made. Heat loss equals to 0 because the system is well insulated. It is a steady flow process. The exchange of kinetic energy and potential energy equals to 0. Lastly, there is no work done onto the system. All the assumption value in the calculation is carefully selected based on valid articles.
Ask us to determine the amounts of power generated from the turbine. Saturated vapor from the boiler enters the turbine. Energy balance for turbine is obtained by neglecting work in, heat transfer, kinetic and potential energy. Mass flow rate is assumed to be 88 kg per second. So we need to find enthalpy in and out to get work produced from the turbine. Saturated vapor with the pressures of 7 MPa and temperatures of 2 at 5.8 degrees Celsius is assumed entering the turbine. From table A5, we can find enthalpy for the inlet stream. Mixtures is assumed to exit the turbine with qualities of 0.85. With the information available, we will use this formula to get H out. First, we perform linear interpolations to find HF and HFG. We put in the values into the formula, and enthalpy for the outlet stream is found. Finally, we put in all the values obtained into the energy balance. We got 25.94 MW of power generated from the turbine. Assumption is made that propulsions of submarine are the same when surfaced and submerged, but will be different in terms of speed.
Question B asks us to calculate the speed of the submarine. For this question, we are going to use open water diagram to find the thrust. We need to have their 5 values first in order to use the open water diagram. All values is assumed except the density of seawater and the diameter of the submarine. The propeller do not receive 100% power from the turbine because some of the power lost while going through some minor machines before delivered to the propeller. First, we calculate the delivered power by multiply the efficiency with work out. Then we divide the value with 2 pi r and get the value for torque. With this formula, the torque coefficient is calculated to be 0.148. By then, we get the thrust equals to 187 kilonewton.
To find the speed, we assume the velocity is constant and the net force is 0. This leads to thrust equals to drag force, where drag force equals to 1/2 rho CD AV squared and area equals to 130 meters squared. Drag coefficient when submerged is assumed to be 0.01516. Speed calculated when submerged by using drag force formula is 28 knots. While when surfaced, drag coefficient is assumed to be 0.02093 and speed obtained is 24 knots, which is slower than submerged speed. The value of drag coefficient when surfaced was bigger than submerged is because of waves present on the sea surface, which lead to lower speed.
Question C asks us to specify number of blades. For this question, we need to refer Kramer diagram to decide the number of blades for the propeller. In order to use the Kramer diagram, we need to recall back these 5 values from previous question. First, we need to find lambda by using this formula. Next, we need to use this formula to find the thrust coefficient. To find lambda, we need to calculate advance speed first, then put in the value in lambda's formula. From the calculation, we got lambda equals to 0.455, thrust coefficient equals to 0.025. We connect lambda and thrust coefficient in the diagram. And then we got efficiency of 0.981 for 3 blades. We repeat the same steps for blades equals to 4. And we got efficiency of 0.985 for 4 blades. Based on the Cramer diagram, even though 4 blades have slightly higher efficiency than 3 blades, in terms of cost saving, propeller with 3 blades is efficient enough to work the submarine.